I think, can you see it now?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes,
As
sir.
you know that this is actually we have done for, have we write down the algorithm or only discuss this, or
Sir,
we
only
have,
Only
discuss this.
discuss.
we have not
Didn't
write
write
down
the
the,
algorithm.
okay, that's fine. I was asking actually one question, at least one question from here to all the students. Um, so that I found like a few students, as a question actually come out, like students come to know at the later part that what kind of questions are actually asking in the Viva. And we have found that this is actually getting what common 2 3 question was there, like octant, the properties of the octant. Few student answered, but most of the student could not. They try to tell about the formula of P of I or decision parameter that actually we are going to discuss. But the main concern was actually that octant from top to if you can see like the first octant, that those points we are going to actually identify the pixel values for them. Those are actually the reason that we actually segmented, or this is called the symmetric property, that segmented that 8 equal part of a circle, and then can be, we can find out the pixel values like those points, and then we will reverse actually in the second octant, then finally we get the first quadrant, then we will change the sign of those quadrant points, and automatically we can get other quadrant values. That was one of the question. Another concern was actually, you see here that we have said that our circle has to be, must in the center, should be on the origin. That is actually the precondition we mentioned. Um, if this is satisfied, then only we can think about this algorithm, otherwise not. So that's whenever it is actually on the center, then only every quadrant values that we can actually change the sign, and we can then actually get it, means all the points for the circle circumference. Okay, so that is actually the properties of the circle we have discussed. Now, on the concern of decision parameter, whatever actually we have felt like that that should be as like in the Bresenham line, that what scenario can happen. So that's why we have discussed about this. A line is actually passing through the pixels like this way for the circle circumference. Consider it is maybe say um, at the place of first octant. That's it's going down from y coordinate to x coordinate, and however one of the pixel has been selected, say like that is having coordinate value xi and yi, and the line for the next two of the pixels that they have, which one should be selected, that is actually the concern that we are going to take. So that's actually the upper one or the lower one. So upper one having the coordinate that xi plus 1 and yi, that means no changes in the y coordinate value, and lower one is actually xi plus 1 and y coordinate is a decrease. It will be sequentially decrease when it goes down. Every cases the x coordinate values are actually increasing by 1. Now this decision that how and how we can actually find out mostly that two of the pixel, which one should be selected. Now that midpoint concept has been considered here, they have identified actually the midpoint between those two of the pixel, which is in that point you can see, and that midpoint having the relationship with the circle, that line, that is actually to take it out. Now, what actually we have implemented here, as like in Bresenham, we have used the line equation, the generic line equation. Here we have considered the generic circle equation, and that generic circle equation is actually x minus xc plus y xc square plus y minus yc square equal to r square, where xc is actually the center point value, yc is center point value, and r is actually the radius. And as we consider that this circle is having that its center point on the actually origin, so that the center value is actually 0 0. So xc is 0, yc is 0. So if we put those value xc and yc is 0, then we get actually x square plus y square is equal to r square. So if we bring that r square in this sides, then the equation become x square plus y square minus r square equal to 0. So that we are getting that equation will be applied in that the circumference point. So if it is satisfied, we know that the point is actually on the line, then definitely that equation will return the 0. So we considered that three possible scenario with that line and the relationship with the midpoint between those two actually pixels. So we have find out that if the line actually goes exactly on through the midpoint, that means that midpoint is actually on the circle circumference, then actually that equation will give you equal to 0. Now uh, what actually we can consider then? Now this is actually we have find out in the Bresenham as well. During your exam you had a problem, that what actually you can see, you see that we have said you can go for positive, you can go for negative for any of the value, and at the same moment you can go for next decision, successive decision parameter on the base of it. Now if better maybe you take the positive. Now, in this case, it will be the same as well. You can go for positive, you can go for negative, any of the concern if you get the 0. Now, what will happen when you have found your that midpoint is actually outside the boundary? That means the line is actually going before that point is actually arriving. That is in between that midpoint. Then we can consider that midpoint is definitely greater than 0. That means actually it's going in outside, and if it is actually greater than 0, that means we are telling decision parameter later, but that equation is actually applied on that point and it is getting actually greater than 0. That's why it is in outside. So we can consider at this moment in this scenario that should be the lower one would be actually considered. Every time you can see that whenever it is going, the point is in outside, the lower one is actually more preferable to consider. And if the line actually goes in outside, that means that point midpoint is actually inside the circle, that then we can understand it is lower than the 0. That means could not reach on that line. So that less than 0 is actually negative, and if it is negative, then actually it is better to the upper one. If it goes actually the upside, like this one example, you can see that it is going through the upper one, so that it is better to take the upper one. So that was actually the concern. Now this equation, whenever it would be applied, it can be considered with that p of I, or the decision parameter to consider. Okay, or we give it a name to decision parameter. So it is understandable whenever a decision parameter, what are the possible that sequence we need for the algorithm. As we know that decision parameter definitely a p of I, we need to start that process of this drawing algorithm, drawing the circle in the algorithm. What actually the values we need first? By default, we consider the precondition is actually the center is in 0 0. That's fine. Now what else the value you need to start this drawing the circle? Yes.
So the value of radius.
The value of radius, yes. So that you need the radius value, then the circle algorithm can be started. We got the radius value, that's fine. Now for starting the algorithm to get the point, we already know that there should be a point in there. What point? That r and 0. That means this point, isn't it? The point of that value, if my r is actually 7, we are saying, then definitely the first point we can consider in here is actually what? We can consider that this is r and 0, right? That means actually 7 and 0. Now what should be the next point? The next point should be in somewhere in here. Now this next point, how I can actually identify it? We definitely need to come now with the decision parameter and to start with, so that we need a decision parameter which is p naught. Okay, then with the p naught I will get my actually second point. Many students made mistake here with the decision. I found like in section C maybe that they made a mistake in the Bresenham. Which mistake? The decision parameter, the initial one that you will get, that initial one will give you the second point, but they start with the first point. Okay, whatever the point is, when you start with the first point, so sequentially the all the points they have got, and also the values are all wrong actually, because this is already plotted. You take a decision parameter to check to get the second point, then you have a successive decision parameter. Okay, and that successive decision parameter will give you actually third point. At the same time you get the your successive decision parameter, you're continuously
Sir,
getting
that
it.
means in Bresenham X1, Y1, that was the plotted value, first one.
First one, and by default that is already plotted. Your initial decision parameter have no relationship with that. What actually relationship it has? For Bresenham I'm talking about, when you have a decision parameter, if it is positive or negative, on the basis of that second point you will get which will be in affected, or maybe if it is 7 will be 8 here. Okay, if it is 0, if it is positive then 0 will be 1, if it is negative then 0 will be 0, right? This is, I'm again talking about actually the Bresenham. So many students started this one taking in here, and which is actually his first point, so the entire process gone wrong.
So that time, sir, the first point was missing, sir.
Now first point is not missing. First point is actually they are considered with the initial decision parameter in the table. So what is actually happened, the other pointer started to come actually wrong, because if you consider that one 70, then this is actually say like positive, then you take a successive decision parameter for that as it is positive. And what is actually done, the successive decision parameter you got, and it is positive or negative, then you get your second point here. And because it has a value, so it will have started to infect actually that one. Okay, whether you will find like third to fourth point that there is a change, or maybe at one of the point you will find actually it's a change. And also it started to get that value, maybe plus minus you are getting in right sequence, but the values of the plus minus is actually getting different. Okay, so because it has a specific procedure, you cannot actually change the steps by your own unless you do mistake. So the same thing actually we are going to do for the algorithm. Let us go for writing down the formal algorithm for it. And you can see here that in the algorithm, uh, we first actually go for in step one. So midpoint circle. So the step one, so input the radius at first, as you know that we need first the radius, which is r of the circle, when we know the center of the circle is, which is xc and yc is equal to 0, 0, which is actually the origin. This is by default, and we said like the precondition, all the cases that has to be like that. Okay. Now in the second step, we have seen that we need actually the uh, initial decision parameter, so that we need to calculate, and we have got some actually a formula that what you can remember about the initial decision parameter for the Bresenham. Like the same way we reach in at some point of that the initial decision parameter for this algorithm as well. So to calculate the initial decision parameter, value is, which is P naught is equal to 5 by 4 minus R, and we consider actually the integer value here, so that's why we take it out like P naught is equal to 1 minus R. Okay, that we actually consider to use for every cases. Whenever we have the radius, you can see that the initial decision parameter will be 1 minus R, that radius value. So most of the cases, you can see the algorithm for the initial decision parameter start with the negative value. Okay, and now we will go in the step 3, where actually we are going to consider same loop that one to another, all the points that we are going to find out for that sequence of those actually pair of those actually the pixel that we have. So in step 3, that at each of xi position, each of x of I position, uh, so that starting at I equal to 0, we will perform the following test. So that is actually if P of I is greater than 0, okay, uh, then what actually we are going to do, the next pixel along the circle line should be when actually P of I is actually greater than 0. That means this situation, so this is actually the midpoint is actually outside the boundary, and then it is better to take the lower one. When it is actually the midpoint is in outside the boundary, then it is better to take the lower one, so that we are the pixel that we are actually picking up is lower one, so that x I plus 1 and y I minus 1, right? The lower
Okay.
one where the y coordinate value is actually lowering there. Yes, Pratasha?
So can you say it again? What is it? Is currently at each of xi position, then what you write again?
Sorry, say it again. I
Sir,
didn't.
can you read this line again? At each of xi position, then what?
starting at uh, I equal to 0. That means actually we are initializing the value for I as a variable.
Okay, sir.
Okay, so we will perform the following test so that whatever the coordinate value we have got already, you see that this is the second point that we are going to get whenever xi plus 1. That means xi is actually what? The first point, which is already you have decided, like 0, 4, r0, right? And then we go for the successive decision parameter. Okay, that is actually important to find out for the which is that the positive one, isn't it? And the successive decision parameter is actually pi plus 1 is equal to the previous decision parameter, and then plus 2xi plus 1 and plus 1 minus 2yi plus 1. You see that this value for xi plus 1, that means whatever the uh, point you are getting, that point's twice value or double value you are needed. So after the equation that we have got, putting that actually circle equation on the midpoint, we have actually generated those equation as like in the Bresenham we have seen. Okay, so the same way that in your table you need to find out actually the double value of the each point that you are getting. So during the actually problem solving we'll see how it is, and that is actually coming with the equation with the previous decision parameter. Then we'll get the successive or next decision parameter.
Sir, is this from R0 point, sir?
R0,
Sir, the first point, sir, sir, xi, yi.
that is R0, yes. Then we are, whenever we are started with the initial decision parameter, okay, that is actually going to give you that second point, right, on the basis of the
Yes,
value
sir.
of it. Now what is this pi at this case? Pi is actually the initial decision parameter. That is the mistake many students did for Bresenham as well that I mentioned. What actually they have done, they thought this decision parameter has given them the first point. Actually not. You need to get the decision parameter and start the algorithm from there. Now, what are the otherwise how you will get the decision parameter, right, or pi? Now, this is actually that one. On the basis of that, you will get actually your second point and also the next decision parameter. This decision parameter will give you the value, the third point, right? Okay. Now, otherwise, for when it is actually the negative, that p of I is less than 0. So the next pixel along the circle will be that as we know that if it is when it is actually negative, then definitely we are going on the upper one to take. That means negative means the midpoint is in outside the boundary. Sorry, midpoint is actually inside the boundary, so that actually it becomes negative. So we are going to take actually the upper one, and in case of upper one, our y coordinate value is not changing, so that the pixel that we are getting is actually xi plus 1, it's increasing, yi is same, okay, and the decision parameter, the next one p of I equal to that the previous one p of I plus 2xy plus 1 and 1. So here there is also a pattern, you can see the x value will be multiplied twice and the 1. So you can see that whenever we have actually the positive, that twice of the y is actually subtracted the value with the next decision parameter to find out, while that is actually it is negative, then only that is added with actually that 2xi plus 1. So there are chances that the value of it is actually going, as it is negative, should be positive at some point. Okay. And this activity of this decision parameter and finding the pixel will continue until, as you can remember, that how long actually we need to go. If you can remember that we need to go this activity from that point to go down is in the first octant. Okay. And that first octant, that point indicating this is actually a point where you are actually chances to have your x and y value is actually same, that means equal. Now this is a concern that if it is not equal, it can have, yes, there is a chance that it is not equal. What it can happen at the very beginning, that your value for x coordinate was 0 and it is started to increase. Understandable, because I am actually moving like this way, right? And the same moment the y coordinate value is actually decreasing because I'm going down. So the value for x is increasing, the value of y is decreasing. So that is actually chance to keep a point. Then so that it's actually um, that's why actually it is getting what chance of becoming two of them are actually equal. If they are not, okay, if they are not, then maybe at some point the x value will be high and the y value will be low. So my algorithm is either any of this situation. If we face, then actually I should stop. When actually x equal to y I'm actually getting, then also I can stop. Also, if x is actually greater than y it becomes, then also actually I can stop. So for these two of this condition can be applied up to your execution point, so that actually we can say like determine the pixels until determine the pixels until that your x is actually greater than or equal to y, right? Any of the situation it can be. Because we cannot say it is an, as it is an integer value, that uh, for two of the pixel, two of the coordinate value x and y will be equal. It is, we cannot say, because it's a huge number of actually that pixels you have. So any one of the case scenario it can happen, like the previous one, maybe x was lower still and y is better. At some point it become like say like it was 2 and 3. In the next point is actually it is considering 3 and 2. Okay, that means you can understand the x has been increased. Now I should stop. That means actually what, 2 and 3, it was now becoming 3 and 2. It is indicating your points are started to reverse. Okay, so now we can actually just reverse all the points that we have got. Then we can get actually up to this point where actually 0r will become r0. Okay, so that's why we are going for until that process of that x is greater than or equal to y. Now simply we will give the statement that what actually we are going to do in step 5 is it says determine the other points of the second octants. Um, First octant have been got, so determine other points or other pixel that points of second octant. How we can get it? By reversing the pixel values of first octant. Okay, and then we get actually, this is an extra actually statement. Then we need to change the sign of the first quadrant pixels. Okay, so whatever the pixels values we are getting of this one, as you can see, that whenever that the first one we get with the algorithm, then we reverse the points, so we get actually all the points in here. Okay, so if it is we get 5 points here, that it is understandable we will also get 5 points here. Okay, so this 10 points now, that are 10 pixels now for one quadrant. Now I'll change actually the sign of those 10 pixels, and we'll get actually the second quadrant value. Say like all are minus x, then we'll get actually the second quadrant value. So whenever actually it is the third quadrant, we change the value in minus x and minus y, and for x minus y if we do, then we will get the fourth quadrant value. So the entire circle, all the points. So 10 means actually 10 in here, 10 in here, and 10 in here. So all 40 of those pixels will construct that the circle. Okay, so that's actually we are trying to write that whenever we found the first quadrant values with these two octants, then we need to change the sign of the first quadrant pixels, and uh, we will get actually we will get, because we are not determining here the other three quadrants pixels for the circle. Okay, so this is actually the algorithm, more common or more actually the same format or method they have applied, as you can remember, with the actually Bresenham's for it, right? Do you have any question? Because
No,
we
sir.
will go for actually an example to do. Let's see that also we'll quickly plot. Anyone have any question?
Can you please tell us the marks today?
No, I cannot. I will give you the script, maybe would be better, because otherwise it will take the entire time. Okay. Now every minute is very important, as you know that for you as well. You will get the script and mark. I will be busy up to tomorrow, and have a plan. If I get free time at night tomorrow, then maybe I will upload. Just have a patience, okay? Because if I tell you mark, it will not actually means how it will help. If I could have show you your script, would be better actually. That before giving the grade, that can maybe help.
Okay.
But overall, the written mark is better, because as you know that all are actually mathematical things. One question is actually on the analytical. There are some students just copied the few slides about the virtual environment and all these things. That actually I have given them less than 50% mark in that type of answer actually. So that question also actually make a student differentiate the students most of the cases, because the student in a rush, when they do copy, as you know that they do mistake, even though they have the answer, but when they copy they do mistake. That is identifiable actually, that who has done the copy. um, Shornika, have you left? Maybe. Okay.
Maybe, sir. She's facing network problem.
Yeah, I think so. Sent a message about in outside maybe, that I wanted to leave. Anyway, so if we don't have any question, let us go for an example for how actually we can solve the problem. As I can see that whenever it has actually mathematical problems, and it is also actually becoming easy for you to many of you who do copy, and that actually we have found like how we can actually stop it. Maybe we can also go for more analytical question now for the final I'm talking about. And it is better to request actually that if your Viva marks could be increased the weight, 25% is not actually sufficient. Some student have that actually problem when they had somehow not very good like mistaken in the written exam, but I can see they're performing better in the Viva, but somehow it is actually not helping them. Okay, let us go for an example. Say like it has been given a circle radius, like this, given a circle radius is r equal to 10. So we can say like demonstrate the midpoint circle algorithm. Midpoint circle algorithm by determining positions along the circle of trend in the first quadrant and then find out all the circle points and plot them on the graph. This is also very interesting find out that I have seen. As I was saying about your that Bressenham, whenever you have actually taken your initial decision parameter and you put in the table with the decision parameter value with the first point, which is actually given. But interestingly, in the graph, you did not, many of you did not put actually the first point on the graph. You started to put from the second point that is actually maybe coming through the table. And you forgot about the first point to plot. Okay. So that is a very common mistake I have found. I don't know why you did not, because you have to put all the points so that the circle can be, that line can be actually seen. Okay. So in this case, also in the question has been mentioned whenever it's saying about the plot them so that you can understand your graph activity also has to be done. So in the solution, we go for in the first octant, we have around 10 minutes left, so have to be a little bit quick. So in the first octant, we just actually define our first point here, the x coordinate value of the first pixel will be 0, right? X coordinate value, because we know that this is actually going what? This is actually talking about this first point, right? As we know in the first octant. So definitely that the x coordinate value is 0 and the y coordinate value is r, that the radius that we actually have, right? So in the first octant, the x coordinate value of the first pixel will be 0 and the last value and the last value for x and the last value for x can be what? Can you tell me that last value can be what for the first octant? The x value for the last one can be this one, right?
X
What it
greater than
should be,
Y
it
or X equal Y.
x equal to y. There are chances that the last value for x will be that value for x will be y itself, right?
Yes, sir.
That means actually we are talking about is our we are going from 90° to 45°, right? That's actually, this is, if it is actually entirely 95 degrees, so we can understand that first octant should be actually kind of in 45°. So 90 to 45° that we are actually talking about, the 45° point, maybe the x value would be equal to y. Or maybe it can be greater than y. If it is, then we can understand it is now exactly crossing that the first octant point. Okay. Now we got the point. We need to actually the initial decision parameter to go with this the second one that we are going to say. Now the initial decision parameter. Now the initial decision parameter P of naught is equal to what? 1 minus R. So my 1 minus 10, R is actually 10. So that we can got P naught equal to minus 9, right? And the initial point or the first point, and the initial point is pixel is actually what? 0R, isn't it? 0R. That means actually 0 and 10. This is actually my first point, or we can say like x naught, y naught, or something like that. Okay. Now we will find out, we will determine, or we will calculate. We will calculate now the successive decision parameter and the successive decision parameter and the pixel positions for the first octant of the circle. Okay, so that we can see we need actually a table for it. Okay, and the table having the columns for actually our iterator first. Okay, then our important part is actually our decision parameter. Okay, that is p of I. Then we need actually the points that we are going to find out, which is xi plus 1 and yi plus 1, the next points or pixels. And we need actually, you see in the formula that twice value of xi, that means the coordinate values, the twice value, and the yi coordinate value that we need. So twice xi plus 1, okay, and twice yi plus 1. So every time whenever we will get the coordinate value, we will double that one. Okay, we'll make it actually double that one. Now always, that's why I write whenever I solve the problem that the first point already I have got. Okay, that is the first point actually I have already got. Now the decision parameter I have got for my first iteration is actually minus 9. Now, if we write down in here, then automatically we will not do mistake to putting that value in here, so that you can understand that I will going to get actually for that one, and then only I can use it. So for the, that is actually negative it comes, right? So negative it comes, we have seen, that means actually if it is negative or less than 0, then what is happening, x is incrementing, y is actually same, y is not changing. So my x is actually incrementing, so 0 is becoming a 1, and the y coordinate value 10 should be same, right? That we are actually getting 110. And at the same moment, we need to twice those values that actually we have got, because we need for the next successive decision parameter to get. So 1 should be 2 into 1 is 2, and 10 is 2 into 10 is 20. Right, that value is actually we needed, and the job has not been done yet. We will go for actually successive decision parameter. For negative, we have the successive decision parameter is actually what, when it is negative, that previous decision parameter, which is p of I. Just for one time I can write p of I plus twice of that x I plus 1 plus 1, right? That is if it is negative. So according to that, if we put the value p of I is minus 9, twice xi plus 1 is actually 2 plus 2 plus 1, right? So that what actually we have got, we got
Minus
actually
6.
minus 6, right?
6.
So that is actually minus 6. Again we got negative, and we get negative, then what we need to do, 1 will be incremented, 2, 10 will be same, so it will be 2 10. And if we do actually that twice, so 2 into 2 is actually 4, and 10 into 2 is actually 20 as it is, because it's not been changing. Yeah. And we go for the next one to find out is again as is the previous decision parameter, which is minus 6 plus twice of that x1, which is 4, and plus 1. Now we get again negative, that is minus 1, right? 4 and 1 is 5, so minus 6 and 1 is actually, that is minus 1. So again negative, so 2 will be 3, and no change for that one is 10. Okay, and we get what? We get actually that 3 is becoming 6, and 10 is actually getting 20, right? And again for the negative, so that we got actually the minus 1, then plus that 6 twice x1, so that's 6, and then plus 1. Now we got actually plus 6, so positive, that for the first time that we have actually got. And for the positive value we got actually 3 is actually 4. We can see that what should be the positive, if we get, then the x will be incremented, y will be decremented, okay, for the first time, so that it will be 3 will be 4, and 10 will be now 9, decremented by 1. Okay, and what actually the 4 is actually going to give you 8, 4 into 2, and 9 into 2 is actually 18, right? And what should be the decision parameter, the formula? We have already said that it should be p of I, then the twice value of that xi plus 1, and then plus 1 minus twice yi plus 1. So that actually the twice value of that y has to be deducted, as you can see in the formula. So that what we are going to get then, with the p of I we have actually 6, twice value of that one is actually 8, plus 1 minus twice value of y is actually 18, right? So that we get value actually 6 8 14 plus 1
Minus 3.
15 minus,
Minus 3.
yes, again actually we got the negative, right? Whenever we got the negative, then actually what happens again, that value for 4 will be 5, but that 9 is actually will be same. And every cases you see that the value is still the x is less than y, So that's why the iteration is actually continuous. Okay, so that we get 5 is now 10 and 9 is actually the 18. As it is actually negative that we have got, so again it will be that formula. So -3, that 2x1 is actually now 10, so plus 10 plus 1. So that we get actually that 11 minus 3 is 8,
8.
right? 8
Yes,
we
sir.
get. So if it is 8, then positive, so that 5 will become 6, 9 will become now 8. That means reduced by 1, and that will be 6 will be 12 and 8 will be 16, and that is actually the fifth iteration. And my success decision parameter will be the 8 p of I, 8, and as it is positive, so that twice value of that one will be added. That means 12 plus 1 and that minus 16. So that if we do the calculation, we get actually that 8 and 12 is 20. So if we 4, we get 4 plus 1 is 5, right? So we get actually the 5. That means positive again. So that whenever we get positive, so 7, 6 will become 7. Now 8 will reduce to 7 as well. You see that now x and y, the value is becoming equal. That means actually we reach in the point for the first octant on that position, right? On that position that actually we have reached in here where the x and y value has becoming equal. So that these are actually the point already we have got for this circle for the first octant. 0, 10, 1, 10, 2, 10, 3, 10, 4, 9, 5, 9, 6, 8, and 7, 7. Now we will do the reverse. We'll do the reverse means what? 7, 7 is actually boundary, you can see. You can reverse, it is same. That means this next point will be 8, 6. Next point will be 9, 5, 9, 4, 10, 3, 10, 2, 10, 1, and 10, 0. So that we get the second octant points. All right. So this is the process. I think the time is up. And tomorrow, next day, actually, we'll just find out all the points here. You can see here that this is actually all the points that you can get after the reversing that for the first octant to get the first quadrant value. Like this, we will change the sign and we'll get all the 4 quadrants, and then we will plot on the graph. Right? Plotting on the graph needs little bit time. That's actually understandable. Okay. All right. Let us go for the attendance. I think you might have some of you have classes as well, maybe.
Yes, sir, we have.
Yeah, just let me
Yes, sir.
quickly do the attendance. Please come to the video quickly.